Okay, so this video we're going to look at parts A through D of your recent quiz for your response questions, and I'm going to go ahead and show you both the work that I was expecting to see and then have a conversation about where the points came from. And assigning the points was modeled off of free response questions from College Board and scoring guides that they typically put out. So to start, it's really important to understand what information you're given. We have the table that shows the number of tigers spotted on the property of Joe Exotic throughout selected months. We are also told that this model is differentiable and decreasing between time is 1 and time is 12, where t, or time, is measured in months and t equals 1 corresponds to January. So a huge piece of information that we're going to have to rely on multiple times is the fact that this model is differentiable. So let's go ahead and take a look at question 1. It says, explain why there must be at least one time t for 3 is less than t less than 5 such that f prime of t equals negative 1.5. And this is a question about mean value theorem. Okay, when we're looking to guarantee a value at which our derivative is equal to a certain value, we're being asked to utilize the mean value theorem. Now, what we have to do is we have to justify that we can actually use it and also explain what the mean value states in the context of the problem. So an appropriate response to this would be that given f of t is differentiable, and thus continuous, we know that differentiability implies continuity. We need both of those pieces in order to apply the mean value theorem. So given that f of t is differentiable and thus continuous, and given that f of 5 minus f of 3 divided by 5 minus 3 is equal to negative 1.5 by the mean value theorem, there then must be at least one time t for 3 less than t less than 5 such that f prime of t is equal to negative 1.5. Okay, so in scoring this, scoring a problem like this, you need to justify why you can use mean value theorem and also state that you're using mean value theorem, so that would be 1 point. And then you would also be expected to verify or to show the information provided in the difference quotient there. So you're getting 1 point for mean value theorem and justification for using it, and then you're also getting 1 point for verifying that difference quotient. Okay. In the next problem, we're asked to explain why there must be at least one time t between time 1 and 3 such that our function f of t is equal to 19. So big difference between what's being asked here is that in A, we're asked for the derivative to equal a value. In B, we're asked for the function to equal a value. So here we're being asked in a roundabout way to apply the intermediate value theorem. Okay, so what we would need to do is, we would have to explain that this is differentiable and continuous here if we didn't in A. If you already did it in A, you would not need to reaccount that information here. But for this question, so let's just assume, since we did, right, we're banking on this information here, right? We're relying on this to use the intermediate value theorem. We need to explicitly state that f of 3 is equal to 18 and f of 1 is equal to 20. And we either need to say f of 3 then is less than 19, less than f of 1, or we need to say that 18 less than 19 less than 20. But we need one of these two forms of the condition in order to use the intermediate value theorem. Okay, so again, we started with saying that it was differentiable and thus continuous from part A. We then analyzed the function values at our endpoints, and we showed that they bounded our value of 19, the value that we're trying to show that our function hits. So then we can say, so intermediate value theorem implies that there must be a time t on the interval 1 is less than t is less than 3, such that f of t equals 19. So here for scoring, we needed to utilize the intermediate value theorem, and also again, if we didn't say it in A, we would have needed to say it in B. That why we can use that is because f of t is differentiable and thus continuous. And then the other point for this problem came from this statement here, right? We need to explicitly say that f of 3 is less than 19 is less than f of 1, or that 18 is less than 19 is less than 20. But those were where your 2 points came from here. Okay, so 1 point for utilizing and quoting the intermediate value theorem, and then 1 point for making that analysis of what our function is doing at either end of that time interval. All right, so C asks us to use a midpoint Riemann sum with 3 subintervals indicated by the table to approximate the integral 1 to 11 of f of t dt. So I'm going to go ahead and actually scoot back up to the table and take a look at that. We're concerned with values along this chunk of our table, and we're asked to use subintervals, 3 subintervals, and we want to use midpoints. Okay, so I noticed that from 1 to 11, if I were to get 3 midpoints, I would have to use the value t equals 3, t equals 7, and t equals 10. Okay, notice that the width of this rectangle that we would be calculating the area of is 4. The height that we would be using would be the output at f of 3, which is 18. The width of this rectangle, right, with a height of f of 7, would be 4 again, right? We have the time that's changing is from 9 to 5, so we have a width of 4 and then a height of f of 7, so 14. Our last rectangle would have a width of 2 and a height of f of 10 or 7. Okay, so an opportunity for a lot of us was figuring out that width. We did a really good job as a class identifying that these were our midpoints and these were the corresponding heights, but we struggled a little bit with the width. Okay, so you want to see if you can kind of visualize this curve, you want to visualize that rectangle whose area you're calculating, and you want to identify that width by looking to either side of that midpoint time value. So in actually writing this out, you would say that the integral from 1 to 11 of f of t dt is equal to our the width of our first rectangle, which is 4, times the height of that rectangle, which is f of 3, plus the width of our second rectangle, which again was 4, times the height of that rectangle, which was f of 7. and then add that finally to the width of our third rectangle, which is 2, and the height of that, which is f of 10. And then using our table of values, we can substitute 18 for f of 3, we can substitute 14 for f of 7, and we can substitute 7 for f of 10. This will give us 72 plus 56 plus 14, which will give us 142. Okay, so on this problem, there were 2 points up for grabs in calculating the midpoint. Okay, so kind of gave you a chance maybe to make a small error, but maybe also not lose a ton of points. So you got 2 points for this calculation, and then you got 1 point for your final answer. All right, so the last one we will talk about in this video is D. So D says use the data in the table to approximate f prime of 2. And then we're asked to use correct units and explain what this answer means in the context of this problem. So a lot of you had no hesitation identifying that f prime of 2 could be approximated by looking at the average rate of change around that t-value. So by looking at f of 3 minus f of 1 over 3 minus 1. From our table, we know that f of 3 is equal to 18 and f of 1 is equal to 20, and then 3 minus 1 is 2. This then gave us negative 2 over 2, which was negative 1. Okay, so that was 1 point up for grabs. This question was worth 3 points. I was looking for 1 point coming from the value, so this negative 1. The next point was utilizing units. So we say that f prime of 2 is equal to negative 1 tiger or tigers per month. Okay, so again, units was a second point. And your third point was the analysis of what this meant. So in the context of this problem, this means that at t equals 2, the number of tigers on the property of Joe Exotic is changing by about negative 1 tiger per month. It's really important here to understand that this work that we've just done isn't saying that he lost 1 tiger in February. It's saying that the rate of change of the number of tigers on his property between January and March was negative 1. Okay, so again, you got a point for the explanation of what f prime of 2 means in this context, the context of this problem. So 1 point here, you got 1 point for units and 1 point for the correct value. Okay, the next video is going to go through part E, and then the third video will go through F, G, and H.